Good afternoon, everyone. Welcome in this another webcast live at EURLab. I'm your host today. My name is Marianne Vinke. I represent EURLab in the Benelux and also in Ireland. And I have the pleasure today to talk a bit more about the standards for ductless fume hoods. And to start, I'm here at the experience room in EURLab in France. And to start, I'll tell you a bit more about EURLab itself. For the people who don't know the company yet, we are a owned company. And we have developed the first ductless fume hood. The first ductless fume hood is actually a recirculating fume hood. So we use filters to purify the fumes that you work with inside the cabinet, inside the fume hood. So that's what we developed, and it's already 50 years ago that we developed the first one. And so until today, we are the leader in the market. And why do we want to give another webcast today? Is to tell you a bit more about the standards, because it's very important. We sell safety equipment. We are the supplier for ductless fume hoods, the #1 in the world. So it's very important to do risk assessment and to provide the right information to the customer. So we are now walking in the production site where we develop and where we manufacture all the laboratory equipment. And we're now going to the lab where we have 15 people working on R&D, research and development. We have, for example, 2 PhDs. We have engineers who work on electronics. We have engineers who work on chemistry. So we really have a team dedicated to develop the filtration technology, but also detection technologies, many different things. And what they also do is they do validation of the standards. So they work on really validating every ductless fume hood we sell, and to look at, okay, what is the application the customer will do? They will be working with different types of chemicals, with different quantities. And so, yeah, that's also validated here. And so I do want to present you my colleague who is Florian. So hi, Florian.
Hi, Marianne.
And so Florian is one of the engineers who is in charge of research and development in the lab in general, but she also validates the risk assessments that are sent to us through the eval request. So when we sell a ductless fume hood, it's very important to determine the right configuration of filters, the right lifetime of activated carbon filters, etc. So that's also something Florian is doing. What we're going to talk about today is the AFNOR NFX standard, so the French standard for ductless fume hoods. And in that standard, we work on different topics, and that's also validated by my colleagues in the lab, who make sure that what we sell is validated and conform to the standard. So let's have a look to the first step, the first validation in a ductless fume hood. So here, for example, we see one of the units. We see one of the units that we offer very frequently, which is the 392 unit with 2 filtration columns on top. And what we see here is the fume hood and how are you kept safe. So one of the first things in the standard that you have to check to comply with the AFNOR NFX 15211 is the air phase velocity. We're going to check that straight away with Florian. And then afterwards, we're going to check 2 other things, which is containment. Check the containment, make sure that all the products, the chemical vapors that are coming free, that they are kept inside the enclosure. And then the third part is to validate or to check the effectiveness of an activated carbon filter. But we're going to tell you more about that straight away. First of all, air phase velocity. So what we see here is that how are you protected as a user from a fume hood in general, ductless or ducted? You're always protected by an air barrier. And this air barrier is, of course, you cannot see the air barrier, but it's very important that it's here and that you're aware of the fact that there is an air barrier. So here is an air barrier, which is created through the airflow, which is going through the fume hood, thanks to the fan units on top of this unit. And I'm just seeing it's a unit with 3 columns and not 2. So it's the 483 Captair Smart and not the 392. So the airflow that goes through the fume hood makes that you have an air barrier here. And that air barrier needs to have a certain speed, an airspeed, an air phase velocity. And to comply with the AFNOR standard, it needs to be between 0.4 and 0.6 meters per second. How do we measure that? We measure that in the lab by using a hot wire anemometer. So I'm going to show you straight away here what the anemometer says. So it's on, and you see that it's around 0.48, 46, 45 meters per second. So it does comply with the AFNOR standards. It needs to be between 0.4 and 0.6. This is, of course, something we do in the lab with a specific anemometer. in a ductless fume hood that you would buy from EURLab, of course, there is an anemometer installed already in the fume hood, which will automatically measure the airspeed on an automatic basis. So you will get an alarm if the airflow would drop below 0.4 meters per second. So, but of course, to comply with the standards, we always need to check it, and it needs to be between that barrier. The second topic, the second test that we perform. Oh, I just forgot something. Just 1 more minute. I just forgot something. So I just spoke about 3 tests that we have to perform: air phase velocity, containment, and filtration. So we'll see those 2 later on. But another thing that's really important in the standards is the chemical listing. So documentation. We need to provide documentation to our customers to make sure that everything is clear and that you're provided with the right information. The chemical listing is part of that. So it's a book in which you find more than 700 products that were tested in the lab at EURLab on their retention capacity in a carbon filter, for example. So you find a lot of information in the chemical listing about all the chemicals we tested at EURLab to make sure that you have all the right information next to the risk assessment that we perform. So documentation, also very important to comply with the AFNOR standard. So now let's have a look at the second step. So the second validation we have to perform in order to comply with the AFNOR standard, which is containment. Also very important. So what we see here is that we have, again, this is a 392 unit, so with 2 filtration columns. And here we have a device which will measure the product that we emitted in the fume hood. So just to give you an idea what the test exactly is, we are going to emit an SF6 tracer gas inside the fume hood. To give you an idea what the SF6 tracer gas is, it's a very heavy chemical, so it will go down in the fume hood. But once you put on the fume hood, of course, the airflow will make sure that all the chemicals will go up and will be absorbed by the filters. But the goal of the test of containment is to check that no vapors are coming to the user. So we test that. So we check what's the amount of SF6 that is still here at the air barrier present. So we want to make sure that everything stays inside the enclosure. And so we test to make sure that there is no chemical coming to the person working with the fume hood. So here you see different sample points in which we are going to detect the SF6. And then the air goes through the tube. And then the air goes completely into this system. And then in this cylinder, and then in this infrared analyzer. So the infrared analyzer will give an idea of, okay, what is now the amount of SF6 detected at the air barrier at the front of the ductless fume hood. And so we can see that here on an analyzer, on the computer, to have an idea of, okay, what is the amount of SF6 detected. It has to be, to comply with AFNOR NFX standard, it has to be below 0.1 ppm of SF6. So very important that it has to be that precise and that low. Another point, so the sampling point we saw, the first sampling point we saw, is a more internal test. So it's very close to the opening of the fume hood. We do another one here with a much bigger sampling panel. So we take a lot more samples, but this is also placed in front of the fume hood at more like between 5 and 10 centimeters from the opening of the fume hood to get an idea of the place where the person is standing, how much of SF6 is still present in the air. So that's also the test we do. The air goes through the tube to the analyzer, and we get an idea of how much SF6 is still present. So that's the second test to comply with the AFNOR NFX standard. To talk about another standard that we also comply to, or ductless fume hoods, is the ASHRAE standard. For people who don't know the ASHRAE standard, it's an American standard, and it goes about containment as well. So here in this corner, we're talking about containment. The ASHRAE standard will, for that, we use this little man who is standing in front of the fume hood. And we're going to see, or we're going to check, that's described in the ASHRAE standard, to see how much of SF6 is still present at the mouth of the person who would be working in the fume hood. So we do as well comply with the ASHRAE standard. Right, so that was the second part. Second test in the FNOR NFX standard. So the third part is about filtration. So as I explained just in the beginning, we are protected by several things. We are protected by an air barrier that we check with the airface velocity, and we are also protected by the filters on top. So there are two ways where we can be exposed to chemicals. Of course, when we have the filters on top, we want to make sure that there are no vapors coming through the filter, and that actually the vapors that do come through are on a very, very, very low level. So to test that, Florian is going to show me how we do that. We put a chemical product on a balance to check how much of the product is in the flask or in the Erlenmeyer in this case. Then we put it through a pump. So there is going to be a transfer of the product through the tube. Then we put on the heater, and then product is going to drop. So droplets are going to come through the tube, are going to evaporate it in the enclosure. So if you have a good look, you see the drops falling down. And then when the heater will make sure that the product is evaporated. And then there is one condition. So in the FNOR standard, of course, you have to follow the strict instructions. And so the goal is that we have here a 200 ppm concentration of the product. So when we do our tests, we always use acetonitrile. I'm just going to check what the products are. So it's isopropanol, cyclohexane, and hyaluronic acid. So these three products are used for this test to make sure that for the filter effectiveness. So of course, it's evaporated now in the fume hood. And then we have two grills. We have one here, and we have one on top of the fume hood. So after the filter. So here we are going to detect or measure to make sure that we have a quantity of 200 ppm of the product, so one of these three products. Once we have 200 ppm, we're going to check there on the last grill on top of the fume hood, so on top of the filter, to check how much of the product is still coming through the last filter. To comply with the FNOR NFX standard, we have to have at least 1% of the exposure limit value of the product. So only if that is the case, we can call our fume hoods that are safe and that comply with the FNOR NFX standard. Right. So let's go to the place where we analyze the data. So when we receive the data from the system, we're going to analyze it here on the computer. And so, for example, here, if you look at the computer more closely, you can see that after 2 minutes 20, we had a peak in concentration that came through the filter. And then, of course, we will transfer that information to a ppm, how much ppm is coming through that product, and it needs to be less than 1% of the exposure limit value. So thanks a lot, Flo, to give us an indication and to guide us through the lab. So yeah, that was about it. It was very brief about, okay, what is the FNOR NFX standard? What are the different steps that we have to follow to comply with the standard? So I hope it was interesting for you to have a look at the different steps. Of course, this was very brief, so if you would like to have more information about one of the things that I explained, or if you would like to pose any questions, ask any questions afterwards, you can always contact us. You can send an email to, for example, salesuk@erlab.net, then it will come to me. So thank you very much for your attention. If you have any questions now, please ask. Okay, so there are no questions for now. If you have any other questions in the upcoming weeks, in the upcoming days, just give us a call, just contact us. You'll find us on the website as well to have more information on Erlab, on our ecosystem, and on our last promotions. So thank you very much and have a nice afternoon.